All right, we're on page 36 in your booklet. There is a warm-up for the quiz you are about to take. This quiz is about the states and changes in matter. You have, I'm going to say, about 8 minutes to work on this warm-up. Then I'll go over it in the video, and then you'll take your quiz. So 8 minutes, pause the video, and after the 8 minutes you can play it and I'll go over it. Pause. Alright, and if the video is playing now, then you must be done with your warm-up. Let's talk about this top section with our heating curve, which shows us the states of matter and how they relate to temperature. So when we have a low temperature, remember that's when we have solids. Medium temperature is liquids, high temperature is gases, which means that right there helps us fill in a lot of this stuff. Solid only is this section number 1. Liquid only is this section number 3. Gas only, section 5. Solid and liquid would be at the section that is between the solid only and liquid only, so that's going to be section 2. Liquid and gas would be between where there's just liquid and just gas, that's going to be section 4. And we know that these sections where you have 2 states of matter are also the sections where you have a phase change. So if you know that condensation is when a gas changes to a liquid, that tells you that condensation is going to happen at the space where you have both gas and liquid. So that's segment 4. And by the same token, if you know that vaporization is when a liquid changes to a gas, then that tells you that the section with both liquid and gas is my section where vaporization happens. That is also section 4. Melting and freezing, we know melting is when a solid changes to a liquid. Freezing is the reverse, a liquid changing to a solid. So both of those are going to happen in the section where you have both solid and liquid at the same time. That's section 2. And for most and least compressible, it helps if you know what the word compressible means. Remember, this word compressible basically means squishable. You can squish it, you can squeeze it down to a smaller volume. So the most squishable, or the most compressible, the one that it is easiest to squish, would be a gas, just like the balloon that I had in the other video. So that's section 5. And the least compressible, where you can't squish it, would be a solid, section 1. Remember that you can compress a gas because all the particles are spread out, so there's all that empty space in between them, and you can squish them down to close the empty space. Whereas a solid, the particles are all really closely stacked together. There's not really empty space to fill when you squish them. Let's talk about question 2. Which of the following has a definite shape? The shape does not change when placed in a new container. It has its own shape. We talked about how gases do not have their own shape. They take the shape of their container. Just like the gas in this room is taking the shape of the room until you breathe it, and it's taking the shape of your lungs. Liquids also don't have their own shape. The liquid in my water bottle is shaped like my water bottle. If I pour it into a bathtub, it's going to be shaped like a bathtub. So it's not liquid or gas, which means it's not going to be answer choice D either. This must be A, solid. For number 3, an indefinite volume, meaning the volume changes when it's placed in a new container. We know that solids, just like they have their own shape, they also have their own volume, so it's not going to be solids. Liquids, the volume, remember volume is how much space it takes up, which means that an indefinite volume wouldn't apply to a liquid either, because if I have 1 liter of water in a water bottle, that's going to continue to be 1 liter whether it's in my bottle or in a bathtub. So liquids have a definite volume as well. They're not the answer to this question. If we know it's not a solid or liquid, obviously that rules out part answer choice D as well, and that means gases have indefinite volumes, which I should know anyway, because we've talked about how gases are indefinite both for volume and for shape. They don't have their own of anything, they just mimic whatever their container's doing. And number 4, you combine potassium chloride and oxygen gas to form potassium chlorate. So we have a reaction here. We can, as we were before, circle the reactants and box the products. And if we notice, we have 2 different things as our reactants and 1 totally different thing as a product. If you're moving from 2 reactants to 1 product, we have different reactants than products. Our reactants are not equal to our products. And when the reactants do not equal the products, that tells you there is a chemical change. When you answer why, you need to do it with a complete sentence. This is a chemical change because the identity of the reactants, let me zoom out a little. The identity of the reactants did change. Your explanation needs to include the definition of a chemical change in it, which is what this first sentence is. And then you also need to prove what you observed that told you it was a chemical change. So you could say the sign of a chemical change observed is, and if we go back to our mnemonic device, please excuse coughs, sneezes, and burps. Precipitation is when you form a new solid. That didn't happen. Our product is not a solid. Energy change, we don't know anything about it. They didn't mention getting hot or colder, forming light or fire. Color change, it doesn't say anything about color change. Smells, it doesn't say anything about that. But bubbles or gas formation, we did form a gas here. So that's going to fall in that category. The sign of a chemical change observed is bubbles when the gaseous product forms. For number 5, you cool iodine gas, creating solid iodine. If we look at our reactant and then at our product, we see that they are both I2. And going from a gas to a solid, I'll point out that is a phase change or a state change. Both of those things tell me this is a physical change. And why, again, you need complete sentences. Your first sentence should include the definition of a physical change in it. So this is a physical change because the identity of the iodine does not change. That's the definition of a physical change we have in there. Then, the iodine going from a gas to a solid, that's called deposition. That's a vocabulary word we're supposed to know. So you could say the iodine undergoes deposition from gas to solid which is a change in state. And if you need further proof, again, looking back at our notes on page 33, changing form or state is a physical change. All right, at this time, unless Miss Woodlock tells you otherwise, it's time for your quiz.